So thank you all for coming. My name is Ryan Grove. I'm on the YUI team. And before I joined YUI in April, I was with Search for about 3 years. So I've been working with YUI for quite a while, especially in the area of performance. So what I want to talk to you today about is achieving performance Zen with YUI 3. And specifically, I'm going to talk a lot about balance and not so much about how to make things go faster. I don't want you to take that as an excuse not to make things go faster. So when you hear about performance, you hear things from all these companies, Yahoo, Google, Microsoft, Amazon. Everybody's kind of getting into this game of talking about making things faster, making the web faster, improving the user experience. And that's great. When you look at the reasons for that, when you look at why we're talking about this so much and why we're investing so much time in it, it essentially comes down to simple economics. I'm sure you've all seen this quote before in a million performance talks. The reason this is so important, the reason performance is so important, and the reason we care so much about it is that it translates into sales. It translates into ad impressions, more users visiting the site, more money. So the simple equation, users prefer fast websites. Faster websites, a better user experience, gets you more users. And more users means you make more money. So this sounds a little bit cynical. It sounds like, maybe we don't actually care about the users. Maybe we only care about the bottom line. I'm not sure that's the message you want to take away from this, but the reason we invest so much time and money is definitely because it's worth it. But you also have a debate going on between, as with anything, you have a debate between extremes. You have one extreme of programmers who likes to say that any form of optimization up front is premature, and so you should avoid that. That's evil. Don't bother optimizing until the user complains, until you hear users whining, until your boss yells at you. Just get it out there, make it work, ship it, and then worry about performance later. I'm not sure that's a great idea. But you have a second extreme that says we must make it faster. We must squeeze every last millisecond out of this thing until there's no more performance to be had. And that's okay too. I think that's a fine goal, but I'm not sure it's a very reasonable or rational goal. I'm not sure it's the balanced goal that you want to take when you're developing a web application. I think where you want to end up is here in the middle, and I think Donald Knuth, who is the originator of that misquoted premature optimization quote, I think he said it best. He says, "There's no doubt that the grail of efficiency leads to abuse. Programmers waste enormous amounts of time thinking about or worrying about the speed of non-critical parts of their programs, and these attempts at efficiency actually have a strong negative impact when debugging and maintenance are considered." He says we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. And I want you to pay attention to the context here. Yet we should not pass up our opportunities in that critical 3%. A good programmer will not be lulled into complacency by such reasoning. He'll be wise to look carefully at the critical code, but only after that code has been identified. So what Knuth is saying is, he's not saying premature optimization is evil. He's saying premature optimization of a certain kind is evil. He's saying spending too much time on those small efficiencies is probably not a good way to spend your time. And here's an example of that. Obviously, this guy over here on the left, that's a situation where it would not be premature to optimize. This thing has a lot of room for optimization. Removing the wagon from the top would be a great place to start. The guy on the right has been heavily optimized. You've had teams of people working on this thing for months, years, making it go faster, making it the best that it can possibly be at the specific task that this car is intended to do, which is to go around a track very, very fast. And that's fine. They've spent millions and millions of dollars on this thing, and it's the best at what it does. But what it does is a very narrow set of things. It races around a track, and it races around a specific kind of track, and that's about all it can do. And it's very, very fragile. So I think that's sort of the extreme approach. The other approach is to find that balance, to find that place in the middle where you're going fast, you're launching yourself off of hills, and you're tackling these insane rally courses, and you can do a wide range of things, and you can do them all very, very well, but you're not wasting time and money optimizing for the things that are in that small efficiency range. You're putting in a reasonable amount of effort. And I think that's where YUI tries to fit in. We try to take the approach of achieving balance, of investing the right amount of effort, and helping you to invest the right amount of effort to get the most gain out of the effort that you're putting in. And the way that we do that is we try to use careful abstractions to provide that balance. Because ultimately, with any JavaScript library, with any abstraction layer, you're essentially making a trade-off between user efficiency and developer efficiency. You're saying, I want to trade a certain amount of the user's time to make my job as a developer easier. Or you're saying, I want to trade a certain amount of my time as a developer. I'll accept a certain amount of maintenance overhead, a certain amount of additional upfront effort to make the user experience better, to make things faster. So YUI tries to hit that sweet spot right in the middle there. We try to hit that sweet spot where you're investing that reasonable amount of effort. You're getting a lot in return, and you're not overstepping the boundary to the point where you're investing so much of your time and so much of your effort that what you're getting back is either nothing or just very, very small gains that aren't actually visible to the user. And the way that we do this is by providing this highly modular library where we support every browser that's out there that's actually capable of the things that we're trying to do with them. And the modular nature of the library is really key to this. The way that we're doing this, particularly in YUI 3.2, which you'll see, we just released the second preview release yesterday. There's a new feature where we're doing capability-based loading, which is essentially where we say, if we have a big chunk of code, say, that is only necessary for Internet Explorer, it's only necessary to fix a bug in IE, we're not going to serve that to mobile Safari. We're not going to serve that to Google Chrome, because it's just a waste of time. There's no reason to execute that code there. And so this makes the library much more suitable for a broad use case, to serve all users, whether they're on a phone or a desktop or whatever system they're using, they're going to get the best possible set of abstractions. But even though we're doing that, even though we're taking care of these things automatically when we can, it's really important for you as developers to understand what's being abstracted, what's going on under the hood, just like it's important for a race car driver to understand a little bit about what the engine's doing. Because we do make certain trade-offs. We increase developer efficiency, sometimes at the expense of user efficiency, but we try to be very smart about it, and we try to provide the tools for you to make the decision where that trade-off occurs, and for you to be able to shift that balance if you want. So if you're willing to take on a little bit of extra effort on your part, you can shift the balance more towards the user efficiency, a little bit less towards the developer efficiency. So the first place that you're going to see this in YUI 3 is with bootstrapping, which is how you get the library on the page. So I'm going to go through a set of simple examples showing you sort of the stages of bootstrapping complexity, starting at the simplest one, going to a slightly more complex type of bootstrapping that's going to be a little more work to maintain, but ultimately will improve things for the users, and then maybe going a little bit too far and showing you where you might not want to end up. So the first thing that you're going to see, and this is what you'll see in all of the documentation, all of the YUI examples, is the simple seed bootstrap. And all of this is doing is I'm pulling in what we call the YUI seed file, which is just the core minimal set of functionality that's needed to get YUI up and running on the page. And this seed file then knows how to go and pull down more information that YUI needs in order to do its job. So if you look in the net panel, you'll see that what's happening here is I've got that initial request for the seed file. And then when I call YUI.use, I'm saying I want to use the node module. The seed file doesn't yet understand all of Node's dependencies. It doesn't know what Node is, but it knows how to go and find that metadata. So the second request is the seed file grabbing the loader module and pulling in all the module metadata for the library. And then it figures out behind the scenes what dependencies are required for Node. And then it makes that third request, which is the combo request for Node and everything that Node requires. So this is a great way to get up and running quickly. It's only 3 requests, which in the big scheme of things might not be too much. You're going to end up spending 239 milliseconds before window.onload. So that's fine. And this is a simple use case. This is only a page with some JavaScript on it. There's actually nothing else on this page. So the next place you can go from here is you can do a seed and loader bootstrap. And this is where, instead of relying on YUI to pull in the loader when it's necessary, you can just load that up front. If you know that you're going to need it, you might as well load it up front. And you'll cut out an additional request that way. So the only difference here is that I've included the loader min file in that initial combo request. So I'm down to 2 HTTP requests. Yeah? Yeah, so the question is, have I seen any use cases where I won't need loader at all, where I'm just going to need the seed? There could be a use case for that. The seed includes, I believe it includes the OOP stuff. There's some very simple stuff you could do. So if you just did an empty YUI.use with no modules, you could get some basic stuff done that way. So yeah, certainly there's a use case for that. In this use case, I'm wanting to use the node module, so I'm definitely going to have to pull in the dependencies. And since I know that I'm going to do that, I can just take that hit up front in that initial request. And even though this request ends up being a little bit bigger, it comes in a little bit faster because the overhead of the additional request isn't there. And so you'll see the overall time, I've cut down the time to onload by 62 milliseconds, which is not bad. And this is an optimization that's maintainable. There's no extra work really that you have to do as a developer. Just add that one change to the URL once, and then you're set. And we can go even further than this. I can say, if I'm willing to take the onus on myself of managing my own dependencies and not relying on YUI to figure out all the dependencies and all the stuff that it needs to load, I can go ahead and I can create this really big combo URL myself that's going to pull in all of Node's dependencies right in that initial request. And then I can say in my YUI config, I can say bootstrap false, which tells YUI, don't bother trying to bootstrap the loader. You're not going to need it. I'll take care of everything. And then just a little micro optimization. I'm using star instead of using node, which kind of bypasses all of the dependency calculations behind the scenes. So it's going to essentially tell YUI, don't bother figuring out all the dependency trees and figuring out whether I'm meeting all my dependencies. I'm smart enough to do this myself, so just run whatever's on the page. Obviously, this is going to be harder to maintain. As I upgrade YUI, or as I add more dependencies to my application, I'm going to have to make sure that I'm including the right modules. I'm going to have to chase down failures when I'm not including the right modules. So this is definitely more work on my part. But I've got it down to one request, and the improvement here is over half of our original time to onload. So it's definitely a big win if you're willing to take on some of that extra work. But you can, if you decide to take on that extra work, obviously you can then shift the balance back a little more by being smart about how you do that work. You can write a simple shell script. In this case, I've written a simple Ruby script to manage my dependencies for me. So it makes it just a little bit easier for me to, at build time, I have an awareness of all the dependencies I need. This is easy to update, pretty easy to keep maintained. And then I can just run this script, concatenate all those dependencies together, create a single JavaScript file that I can push to a CDN, and then I'm set to go. So you can go a little further, though, and this may be too far. And this largely depends on your use case, on your application, on your users. So use this responsibly. The next place you can go is the lazy bootstrap. And what I've done here is I've gone back to the seed plus loader in the initial request. And instead of instantly running that YUI.use statement, what I'm doing is I'm deferring that until after window.onload. So that means YUI is not going to go and inject the script dependency for Node until after the onload event fires, which means that script load is not going to block onload. And actually, in Internet Explorer and in Opera, it's not going to block onload anyway, but this is a good optimization potentially for the browsers where it does block. Now, the catch with this is you don't want to use this on a site where it's crucial that your users interact with your page immediately in terms of JavaScript interactions, because obviously those aren't going to be available right away. So if it takes you a second to get to onload because you've got a bunch of images, and your JavaScript doesn't load until after that, and the user's trying to click things and it's not working, that's not a good experience. But if you've got a page that's more content heavy than JavaScript heavy, if it's more about showing that content to the user and at least allowing them to see it and start processing it, this might be a better optimization. And what this is also going to do is it's going to stop that browser load spinner from running. And you can see this gets me down to a much lower number to onload, but it might be a fake number. So this could be a trap. You might not want to do this. This is a situation where you want to really test, measure, understand how your users are using your application, and make a responsible decision about where to set that balance for yourself. So that's sort of the stuff that YUI can do when you start it up. Once you get YUI onto the page, there's some additional stuff that YUI is doing behind the scenes that just takes care of things for you automatically. There are a lot of optimizations in terms of where native browser APIs are available for different things that you're doing. YUI tries to make very smart decisions about using those APIs when they're there, emulating them when they're not. So this is all stuff that you get for free. That's the slide that says exactly what I just said. Yes?
So what is the recommendation, onload or on-DOM ready?
So the question is, do I recommend waiting for onload or waiting for on-DOM ready? I would recommend if you're trying to do something as soon as possible to make it able to be interacted with, on-DOM ready is a great way to do that. That's going to generally fire before onload. The reason I talk about onload is because that's kind of a benchmark for where the perceived performance limit is. Essentially, you can make something interactive before onload, but the browser load indicator is still going to be spinning. You're still behind the scenes. If you're monitoring round trip on the page, that's still going to be counting up. And there are some other things that are happening before onload. So, like I said, depending on the use case, on the application, you might want to shift some of that upfront work after onload. But if you're only doing a little bit of upfront work, obviously the sooner the better. So, so native APIs. So here's an example of the first use case you're likely to run into where YUI is just going to optimize things for you behind the scenes. So I'm doing a very, very simple CSS selector here. I'm saying, find me the first node on the page that has the class name foo. And behind the scenes, what YUI does, you'll call into the node object, which calls into the selector module, which knows, based on feature detection, whether or not your browser natively supports CSS query selectors. And so it can very quickly and very smartly decide, if I don't have native support, I'll emulate this. It's still going to work fine. Even complex selectors, even CSS3 selectors, YUI is going to provide that support for you if the browser doesn't. But if I have a native API, I can go directly to that native API, bypass all the emulated stuff, and get a nice speed up. And in this really simple case on a small document, the native API is 1.5 times as fast. With a more complex selector, with a more complex document, you're going to see a much bigger improvement there. And this all happens behind the scenes automatically. You don't even have to worry about it. So another great place where this happens is the JSON module, which we're starting to see native JSON APIs, which is great, absolutely good for performance. But we still want that to work in older browsers and in less capable browsers. So again, behind the scenes, you're calling into the JSON object. It knows based on feature detection whether you have a native API available. It's going to give you the emulated one if it's not supported, native API if it is supported. And in this case, you're going to see a really significant speed up. 22 times as fast at parsing, 19 times as fast at stringifying in this particular benchmark that I did. And the really nice thing about JSON is that the YUI abstraction above the native API has very, very little cost. The additional cost over just calling through the native API directly is extremely minimal. And in addition, YUI can make smart decisions even if there's a native API there. Some of the earlier implementations in browsers, like in Firefox 3.0, when they first pulled in the native JSON support, there were some quirks, there were some edge cases that you could run into with buggy implementations. And YUI knows about that. So even if that native API is there, if you're using one of these browsers that has a quirky implementation, YUI can shunt you to that emulated version and make sure that everything works. So a great thing that's coming in YUI 3.2 is CSS transition support. So Matt's created this wonderful new API that not only abstracts away a lot of the complexities of working with CSS transitions, but also ensures that you're using that native transition support if it's there, and provides a fallback to JavaScript animation when it's not. And so a CSS transition is essentially similar to what you've all probably seen in terms of JavaScript animations, where you take an element on the page and you say, I want to go from this set of style properties, from this height, from this width, to another set, and I want you to do it smoothly, so animate it there, and do it over this particular duration. So what I'm doing here is I'm setting up two transitions that are going to run simultaneously, and I'm saying over 1 second, change the height of this demo object, this demo node, from whatever it is now to 10 pixels, change its width to 10 pixels, and then also at the same time, over the course of 2 seconds, change its opacity from whatever it is now to 0. And behind the scenes, YUI is going to manage the complexity of vendor prefixes on the CSS transition API. It's going to handle the complexity of figuring out when those two separate transitions have both finished so that it can fire your final callback. It's going to run that for you. It knows, again, via feature detection, what the browser supports. It'll shunt you to an emulated version if it doesn't have a native support. If you've got native transition support, in this simple case, I saw 32% less CPU usage, and this is in Safari 5, compared to when I disabled the native transitions. So that's really nice, especially if you've got a lot of stuff going on the page, and especially on mobile browsers, which are starting to support native transitions, and even have hardware acceleration for them. And again, you get this for free. You just use the API, and it happens all behind the scenes. So that's what YUI does for you automatically. That's the stuff that you don't really need to worry about. There's also a set of things that you do need to worry about. So when you get beyond the places where YUI can make the smart decisions for you, YUI also provides tools that you can use to find balance in your own code, to make sure that the things that you're doing outside of YUI or on top of YUI are as performant as possible. So I'm just going to run through these really quickly. There's actually a lot of depth here that you could have a talk about probably each of these components that I'm going to go through. So I'm going to give you an introduction to each one, and I encourage you to check them out later. Look at the documentation, see what you can do with them. So the first one, and probably the simplest one, is the y.cached method, which is available in the seed, so it's always there. It's just right on the core YUI object. And this just provides simple function memoization. And what memoization does is you pass in a function to the y.cached object, which wraps it in another function. And from then on, whenever you call this wrapped function, based on the inputs that you pass in, and actually just based on the inputs that you pass in, it's going to cache the return value of that function. So as long as you pass in those same inputs again, you're just going to get that cached value back. You're not going to have to run that function again. So if you're doing a complicated computation, or in this case a recursive computation, you can see a benefit here. So this is just a simple recursive factorial function just to demonstrate what's going on. It's actually not very expensive, but to demonstrate how the recursion is helped here. On my first call, I'm going to see 150 function calls from trying to find the factorial of 150. On my second call with the same number, one function call, it just goes straight to the cache, pulls back that cache value. And the nice thing about factorials is, due to their nature, since I'm recursing down with each number, if I call in with a smaller number, I'm still going to get one function call because I've already run that function, and it's already been cached as well. And then if I call in with a larger number, 160, I only hit 11 function calls. I do the 10 to factor the numbers from 160 to 150, and then finally the 1 that's just going to give me the cache value of the previous functions. So that's really great for very simple memoization. The catch there is there's no limit to the size of this cache. So if you're just caching things and you're calling with a lot of input values, you're going to fill up your memory. So you need to be careful about that. But that's where the cache utility comes in. And the cache utility provides a slightly more complex cache, just a key value cache, that allows you to specify either a limit on the number of items, or you can specify an expiration time. You can say, I want these items to expire after a certain number of milliseconds. And this works similarly. What I'm doing here is I'm instantiating the y.cache object. I'm setting a maximum limit. I'm saying only store 10 items in the cache. And after I hit that limit, start knocking out the least used items. And then all I'm doing in my bogus expensive function here is checking the cache first for a result for the particular input value. If I find the result, I'll return that result. if I don't find it, I'm going to go ahead and do this silly, very suboptimal calculation. And then I'm going to cache it and then return it. So the first time I call this, obviously, with a large number, very expensive. It's going to take about 360 milliseconds. Second time, less than 1 millisecond. Just go straight to the cache. And this is cached in browser memory. So there's a new utility coming in YUI 3.2, the cache offline utility, which shares an API, and it shares the base implementation with the cache utility. But on top of it, it adds the ability to use local storage as the cache store. So you're calling in with the same API, but behind the scenes, it's putting things in offline storage, so it's going to persist across page views. And the only difference here is instead of instantiating the cache object, I'm instantiating cache offline. Cache offline doesn't support a maximum item limit, but it does support expiration. So I'm telling it expire this thing after a certain number of milliseconds, which comes out to 30 minutes. And then everything else is just the same as before, same API. And so if my browser supports local storage, obviously on the first request, I'm going to see the same thing I did before. If my browser supports local storage, I can then go away, navigate to a different page, come back, close the browser, whatever. As long as I come back within 30 minutes, I'm still going to benefit from that cache. If the browser doesn't support local storage, it's just going to fall back to a memory cache, just like the normal cache utility. So it's a really nice thing. If you're doing rare, expensive calculations or expensive calculations that can benefit from remaining in a cache across page views or across sessions, then it's a really simple tool to use. The next utility that I'm sure you've all seen or at least read about, this was also in YUI 2, is the image loader. And this is a really simple tool that's also very, very powerful. And all that it does is it tries to provide various methods for lazy loading images. So if you have a page with a lot of images on it, some of which only appear based on certain user interactions or some of which are hidden below the fold, so there's no point loading them until the user actually scrolls or resizes, this can take care of that for you. So in this example, this is just a very basic example of a fold image loader. And so I'm instantiating an image load group, and I'm telling it, for this group of images that I'm about to give you, don't show these images until they're within 25 pixels of the fold or above that. And then I just pass in, I register a bunch of images, I tell it where those images are, and those are mapped to the image elements that I created earlier that don't have any source attributes. And so image loader is going to automatically handle pulling in those images at load time. So you'll see when I load this page, I've got my first two images above the fold. Those are loaded instantly. I only have the two requests here. And as I scroll down, as soon as I can see that third one, it pops in. So really easy to use, really beneficial if you have a page that has lots and lots of images. Can definitely help performance there. And there's also a lot more depth to the tool. You can define not just based on the fold, but based on interaction, based on clicks, based on mouse overs. So it's worth checking out. Another tool in YUI 3 that doesn't get a lot of attention, I think, and I think it should, is the async queue. And so this is a simple utility. Well, I say it's simple. It can be simple. It also has, like the others, a real depth of power just in terms of the things you can do with it. The point of this utility is to make sure that you're not blocking the main UI thread. Since JavaScript shares a single thread with the UI of the browser, and since you might be doing other things in that thread, like reflowing the page or rendering things or loading images, whatever, running other JavaScript, processing user input, mouse clicks, things like that. If you're going to do a lot of work in JavaScript for some reason, you don't necessarily want to do that huge chunk of work and just block that thread. So async queue provides a very, very simple API for splitting that large chunk of work into smaller chunks and saying, essentially run this chunk. And you can see I'm passing in three functions here. And what's going to happen is async queue is going to run the first chunk, and then it's going to return control to the UI thread. So it's going to process any outstanding user events, any outstanding JavaScript events that have been added to the queue. And then it's going to come back and run that second task, and then return control again to the UI thread, and then run finally the third task, and then finish. And async queue takes care of ensuring that these tasks are run in order. It takes care of all the complexities behind the scenes involved with that. And it also provides a wealth of other options beyond just run these three functions. You can also do a whole lot more with the API. So that's another one to check out. So ultimately, the point of all of this, the reason why YUI includes all of these tools is obviously not because we think optimizing up front is premature. We're providing these tools and we're doing our own performance optimizations because we think that you should design with performance in mind. It's not ever premature to sit down and think about an architecture for your application or think about how you're going to design your application and start thinking about performance up front. It's also not premature to take advantage of easy optimizations. If you have a quick win or some low-hanging fruit, if it's just right there, right for the picking, take that optimization. Just do it. If it's low cost, it's high value, you should absolutely take it. What you may not want to do is tackle those harder optimizations, at least not until you've measured, until you've actually established that it's going to be worthwhile for you to invest a large amount of time or a large amount of maintenance in actually performing these optimizations. And I want to stress the importance of measuring in particular. You want to measure before you start tackling these things. First, see how much it's actually hurting your users, see how much it's hurting you, and then think about tackling the optimization and measure after you've optimized, especially if it's an optimization that's going to take a lot of work for you to maintain, because while that's certainly serving the user if you can make something faster, it is a trade-off. Anything that takes more developer time is ultimately also stealing in some sense from the user, because the less time you have to add features and fix bugs, deal with user support requests, that sort of thing, the less you're serving the user. So how do you measure? There are a lot of ways that you can measure performance. Obviously, profiling, benchmarking. There are some bad ways you can do it. There's some good ways you can do it. There are bad tools and there are good tools. I just want to run through really quickly some of the tools. Again, this is a topic that can be talked about at great length and in great depth, but I want to give you an idea of what's out there so that you can check it out. The first one, obviously, since we're talking about YUI, is the YUI profiler. And this is just another YUI 3 module. I can include it on the page just with use profiler. And this gives me a really simple way to directly in JavaScript profile the execution of my functions. I can create timers, and I can say start timer, run some code, stop timer, see how long it took. So what I'm doing here is I'm just doing a very simple profiling example where I'm registering an object that has a bunch of public methods on it. And I'm telling the profiler, just wrap all of these methods. And then I'm doing a bunch of work. I'm using the interface. I'm calling those methods. And profiler is keeping track behind the scenes of the average call time, the number of calls, the maximum time, the minimum time. And then it'll dump all that information back to me in a report when I ask for it. There are other ways you can interact with it. You can pass in an individual method and say profile this method. You can say profile this anonymous method. Like I said before, you can use timers. The downside with profiler is since you're using JavaScript timing for all of this, you're not necessarily going to be entirely accurate. You're essentially at the mercy of the timer implementation in the browser that you're running in. And some browsers, particularly Internet Explorer on Windows, are not very good at providing a good timer resolution. So you can go beyond this and look at other profiling tools. The WebKit profiler that's included in Safari and Google Chrome, this is really, really nice, and it's really simple to use. All you do, essentially, is you come here, hit this nice little button here, do a bunch of stuff, run some code, hit this button again, and you get a dump of all your profiled method executions. You can drill down the call stack. You can see which methods are calling other methods. You can see what's going on behind the scenes. It doesn't really let you sort or organize, terribly well, but it's a nice tool that's available right there in the browser, in the web inspector, and you have access to it right away. Another tool that the Safari web inspector provides, and you'll see this in Google Chrome as well, is the timeline panel. And this isn't specifically for profiling JavaScript. This is actually going to give you a view into everything that's happening behind the scenes of the browser. It'll show you from the initial request for the page to when it starts parsing things to when it starts performing reflows and rendering things on the page, changing the layout. You can see the paint operations in here. You can see individual DOM events. There's a garbage collection event. You can see when memory is allocated and collected. It's a very noisy display of what's going on, but it's also full of information. And you can drill down into these things and get an idea of what's going on at every level of that page view. So that's a great way to dig into the details there. Firebug in Firefox also provides a profiler. This one's, again, very simple to use. Essentially the same as the WebKit profiler. You hit a profile button here in Firebug, go do some stuff, come back, hit it again, and you've got your profile results right there. Again, like the WebKit inspector, it's very simple. You can not really drill down here. You're not going to really be able to sort very well, but it's good for getting an idea or doing a small set of profiling on some specific methods. There's a really great tool for Windows, specifically for Internet Explorer, and unfortunately only for Internet Explorer right now, called Dynatrace. And this tool by itself might actually be reason enough to use Internet Explorer. Maybe. But it provides a wealth of information. This thing goes into ridiculous amounts of detail on everything that's happening behind the scenes in the browser, from network to JavaScript to just everything going on. So I strongly encourage you to check this out. And the benefit of testing in Internet Explorer is that if you can make that fast, the other browsers are going to be plenty fast as well. So there's a new one that's come along very recently. It's an online tool called jsperf.com. And this is really, really great. It's essentially like GitHub gists for performance. So you come to jsperf.com. You can just very, very quickly get up and running with a simple test case. You enter in some initial code. You can pull in any of the major JavaScript libraries, including YUI, to form the framework of your test. You can add some preparation code. And then the whole point is you just have small snippets of code that you want to test and compare to one another. So you enter those snippets in right here. And I'll go and show you an existing test case. So here's a test where we're comparing different forms of string concatenation. You can see all the different snippets here for the comparisons. And I've started the test, and I'm going to see each of those run. I'll see the results come in real time. And it's doing interval testing rather than duration testing. So it's actually testing how many times within a second each of these snippets can run. And so like this one here, I probably had a garbage collection or something in there, so I can run it again and get a more accurate result. And it'll tell you which one is fastest, which one's slowest. And you can come down here, you can add comments, you can see all the other revisions of the tests that other people have made. And then I can go up and I can edit any test on the site. Anybody can edit any test, create a new revision. I can fix a bug, I can add another snippet to compare. And then I'll create my own revision from this, and that'll be saved alongside the other revisions. And actually, since I put this together, just in the last couple of days, JSperf has added a great new feature. They're integrating now with Browser Scope, which pulls together test results from all different browsers and all different browser versions. And we'll show you all of those for each JSperf test. We'll show you the historical results from all different browsers. So you can get a really good idea of how this test is actually comparing across the board. So yeah, I strongly encourage you to check that out. You can browse all the existing test cases. You can see what other people are doing. And there's a really good chance that somebody's already written a test, so you don't have to do any work. So that's a nice thing there. So ultimately, the point of this entire talk, everything that I'm trying to tell you, is about balance. Make things fast, obviously. Fast is good. Our users like fast. But also think about the balance of what you're doing. Think about the effort that you're putting in and what you're getting in return. And when you think about that balance, think about it in terms of user efficiency being at the top. Obviously, user efficiency is most important there. I've just ruined my slide. So user efficiency is most important, but developer efficiency is important too. You can't just think about the user. You need to think about yourself as well, because maintaining your application 1, 2, 3 years down the road, that's going to be an ongoing concern. And if you're spending all your time maintaining your performance optimizations, fixing these fragile things, these clever hacks that you've put in to make things a few milliseconds faster, then that's time that you're not spending fixing bugs. That's time that you're not spending, actually serving your users well. And it's also going to make you unhappy. And nobody's going to stay in a job where they're unhappy, so make things good for yourself. And finally, efficiency for its own sake. Efficiency that doesn't result in measurable improvements for the user or measurable improvements for yourself. If you're not improving either of those things, if you're just doing it for the sake of making something faster, it's probably least important. It might not be harmful. It might be okay to do that. If you just got some spare cycles, and if it's not going to hurt anything, then certainly go ahead and do it. But don't spend all your time here. Don't spend all your time in this realm of small efficiencies. And unfortunately, I can't give you rules for each of these things. I can't tell you this is the user balance, this is the developer balance, this is exactly where you want to be. That's something that you have to define for yourself. And you have to know your users, you have to know your application, you have to know, you have to be able to some extent, predict the future, and be able to find your own zen, find your own balance. And hopefully YUI can help with that. We want to make it easy for you to find your own zen. And that's it. These are my photo credits. I want to give a particular shout out to Alan Rabinovich of the YUI team who drew me that laden swallow image, which was awesome. So thank you all for coming.